Popular demand. We've had at least two of you. One of them's absent today. That's fine. We've had at least two of you ask about position, velocity, acceleration, and so let's go over it, guys. This is our first review on motion, and here we go. This is from the 2004 exam. I don't remember if this is question one or question two, but it is a calculator active question. So here we go. It says a particle moves along the y-axis, so it's moving up and down. So the velocity v at time t greater than 0 is given by, so the first move, if this is a calculator active question, I'm going to type this into your y1. Do not use y1 in the free response. This is just for notes. At time t equals 0, the particle is at y equals negative 1. So there's my position. So sometimes it helps to write the coordinate 0, comma negative 1. Be careful. This is a time, t equals 0, and this is a y value. You're on the y-axis. Cool or not cool? Find the acceleration of the particle at t equals 2. You don't have to do anything other than the setup. I haven't looked at the rubric, so I'll see how many points it is. I'm taking a guess that it's probably going to be 1. All you have to do, how do I get acceleration from velocity? Derivative. You just show that. Chop, how do you show it? Like this. You're going to go acceleration at 2 is nothing more than the derivative of velocity at 2, which equals, and then you give me the number. Here's the velocity equation. So let me first type this into my calculator. So where's my calculator? Did I not push it? Let me push the calculator. All right, here we go. I'm going to go to Y1. Make sure you're in radian mode. Come on, buddy. Okay, here it is. All right, here we go. So I'm gonna go y equals, what was my? Let me clear everything. 712. What was my equation, guys? 1 minus arctan. Arctan of what? E to the t. So e to the x, and like that. That was it. All right, here it is. I'm gonna go to my home screen. All right, guys, focus. All you got to do is go math. Number 8 derivative, numeric derivative at x of alpha trace y1 at x equals 2 because they wanted the acceleration at 2. And there it is. That's it. Type that number in. How many digits after the decimal? 3 at least. You can round or truncate. What's up? Huh? Guys, where'd the papers go? The notes? Yeah. And you want to grab one from it? Negative 0.132. Negative 0.132 or negative 0.133. It does not matter which one, guys. All right. Here we go. Let's go to the next one. I love this question. This is the question that you guys have been getting wrong on the flashcards. Is the speed of the particle increasing or decreasing at time t equals 2? I don't know. This is pretty much like saying, am I speeding up or am I slowing down? So the speed is absolute value of velocity. If velocity and acceleration have the same sign, you're speeding up. Speed is increasing. If velocity and acceleration have opposite signs, you are slowing down. You're decreasing. Does that make sense? So I already know what the acceleration is at 2. A of 2 equals negative 0.132. I'm going to figure out what the velocity is at 2. So I'm going to go alpha trace y1 at 2. And I got negative 0.436. Am I speeding up or slowing down? Speeding up. So that means my speed is increasing. Does that make sense? We're going to say speed is increasing at t equals 2 since velocity at 2 and acceleration at 2 have the same sign. Full credit. Now I want to make sure, don't be a robot. Remember, guys, if velocity is positive and acceleration is positive, that means the force is being directed in the same direction as velocity. You're moving up, and then your speed is increasing. If velocity is positive and acceleration is negative, The acceleration is at the opposite direction of your velocity, so you're decreasing. That's like pushing the brakes. Are we okay? Okay, please ask, guys, because that's one of the questions. I have a feeling we're 100% going to have a velocity question this year. Find a time t greater than 0 at which the particle reaches its highest point. Justify your answer. How do I do that one? How do I find out where velocity reaches its highest point? Yeah, it's like finding a max. So find where the derivative changes from what to what? Yeah, not any derivative, the derivative of velocity. So find where the acceleration goes from positive to negative. So look, check it out, guys. You already have it in your calculator. Your velocity, right? So I'm going to turn off y1, and I'm going to go math number 8 x, and then I'm going to type alpha trace y1 at x. Now, hold on. Don't push graph yet, guys. Notice, let's see. What do we want to notice? They don't give us a domain. Okay, so we're going to hover around the x-axis. So click on window, and I'm going to make it from 0, because there's no such thing as negative time, or at least not in this problem. It says t greater than or equal to 0. And I'm going to start like this, from 0 to 10, and if I need to make it bigger, I will. And I'm just going to hover around the x-axis. I am just looking where my acceleration changes from positive to negative, because that's how I find the maximum for velocity. Does that make sense? Okay. Actually, hold on. Find the time when the particle reaches its highest point. Dang. It's not where the acceleration changes from positive to negative. It's where what changes from positive to negative, not the acceleration. The velocity. Yeah, you don't have to do derivative. Tell me why. Guys.
It's highest point.
It's highest point, not highest velocity. If velocity is positive, you're moving up. Yeah, focus, guys, focus. If velocity is positive, you're moving up. If velocity is negative, you're moving down. If I want to know where the highest point is, I'm going to look where my velocity changes from positive to negative. Is this making sense to you guys? Please. I hope it makes sense. If it doesn't make sense, please tell me again. I turned off my Y2 just in case I need it. So there it is, my Y1. I'm just looking where my velocity is changing from positive to negative. I'm going to push graph. So look, it looks like it's right there. And after that, look, it looks like my velocity is always negative. So I'm just going to look between 0 and 1. So I'm going to click window, and I'm going to go 0 to 1. And you know what? I want to get even closer. So negative 0.5 to 0.5. And I'm going to push graph. And there it is. Bam, right there. I'm going to go second calculate. I'm going to click on 0. And then it says left bound, so I'm going to go to the left. I'm going to push enter. It says right bound. I'm going to go to the right. I'm going to push enter. And there it is, 0.4430. So I'm going to write v of t equals 0. That might be a point at t equals, and I already forgot it, 0.4430. 0.4430. I don't have to say anything there, but I'm going to store it here in A. So I'm going to go second quit. Bless you. Store alpha A. Because I want to store that value. There it is. Okay. And I'm going to say this. I'm going to go particle reaches highest point at t equals 0.4430, since this is the only time in which velocity changes from positive to negative. If you want to be more specific, semicolon, indicating highest point. Indicating highest point achieved. For you STEM majors and medical people, this is what you're going to be doing. You're going to be analyzing stuff all the time. So good thing we caught it. Guys, come on, try and be in your A game. And if I didn't do that error on purpose initially. It just so happens that I was going through the motions when I should have been paying more attention to it. Is this making sense, guys? Okay. Letter D. Find the position of the particle at t equals 2. Is the particle moving toward the origin or away from the origin at time t equals 2? Justify your answer. Okay. Bless you, bless you, bless you, bless you. You guys ready for the position? My position at 2, remember this is on the y-axis. I'm either going up or down. My position at 2, so y of 2, is equal to the initial position they gave me. What initial position did they give me? At time t equals what? -1. Yeah, 0, which is -1. You can put -1 right off the bat. I'm going to say y of 0 plus my displacement. Do we remember how to get displacement? Integral from 0, and then I want to know at 2. So 2. Focus, guys, focus, guys. I know you know it, Ramos, but we need everyone in. V of t dt. Does that make sense? Guys, ask me. Ro, we'll get? Yes. Okay, for sure. Okay, here we go, guys. This is, oh, by the way, this is called a setup. If it's in the calculator section, they do not care about you doing an antiderivative. They just want to know, can you do this? Can you show me the setup? And then just type it in the calculator. So here it is. You have your calculator. I'm going to go -1, because that's what y of 0 was, plus math 9 from 0 to 2. And then I'm going to type in alpha trace my velocity, which is at y1. And there it is. I'm going to put x and enter. So negative 1.360 or 361. So negative 1.360 or 1. Okay, so there it is. Now they want to know, am I moving toward the origin or away from the origin? Well, how do I know if I'm moving toward the origin or away from the origin? I already have my position. I got to find what? My velocity. Yes, guys, look, you got to find your velocity. You already know. Here's 0. Look, negative 1.360. You're below the origin. Yes or no? If my velocity is positive, I'm going to be moving toward the origin. If velocity is negative, you're going to be moving away from the origin. Did I already get my velocity at 2? My velocity at 2 is negative. So am I moving towards or am I moving away? Away. So you're going to write particle. Did they say justify? Yeah, it does. Particle is moving away from the origin since v of 2 is negative and y of 2 is negative. No, I wouldn't say the same signs for this one. I guess you probably could get away with it, but I would not on this one. I would just say, yeah, they're both negative. Or you're below the origin and the velocity is negative, hence you're moving away from the origin. If you want to be more specific, you can, guys. You can say your particle at 2 is negative 1.360 and your velocity is negative, hence you're moving away. Let me look at the rubric for this. I have not looked at this rubric, so let's see how we did. 2004 AB. Math, calculus. College board. All right, here it is, guys. Oh, maybe it wasn't this year. Oh, yeah, here it is. All right. 1 point. But it's an easy point that I think you can get. And I know easy is relative, and I shouldn't be saying that. But I think we can all get this point. Cool or not cool? All right, look at the letter B. Velocity is negative. Speed is increasing since acceleration and velocity are both negative. I love how they said it. They said it exactly how we said it. Cool or not cool? 1 point, letter B. All right, guys, focus, focus, focus. Letter C. Velocity is 0 when this equals 1. Yeah, that's fine. Look, check it out. This is generous. This is why I tell you guys that I think we can get it. They will give you a point just for setting the velocity equal to 0. Can you do that? Can you set the expression equal to 0? Yes, and you get a point, guys. This is why I think we can all do it. Okay, next. Let's see. What do we have here? Did we get 0.443? Yeah, and look what they said. Velocity is positive between 0 and ln of 10 of 1. Velocity is negative for all numbers bigger than that. That's what we said, but we said it in words. We got it. We got it, guys. We got all 3 points. Look at letter D. Ours, they're always going to look the same. I guess maybe there's a slightly different way you can do it. You could say y2 minus 1 equals this because that does equal displacement. That's the only other way that I think you would write it. It's either one of those two. So yours is always going to look like this. The other way that you could write it, maybe you say integral, let me go to the, maybe you say, for this one, you say, well, this means displacement. So let me write V of t. Don't write this down, guys, just listen. This means displacement, and I'm in the y-axis, so displacement is just whatever my position at 2 is minus whatever my position at 0 is. And then you plug in whatever that is, -1, move it to the other side. Those are the only other two ways that I think you can do it. So I want all of you to always look like that one. Yes, you can make it look like this one as well. Because remember, that's what integral of velocity is, right? Displacement. And there's motion on the y-axis. Look, this is displacement, y2 minus y0. Whew, that was good. Do you guys feel good? Are we getting? I don't want to waste your time, guys. Is this making life better for position, velocity, acceleration? Is this clearing things up? Okay. Because if I'm